I'm Pulaha Roy. I am a data journalist with the Down to Earth magazine. And today we'll be doing some analysis on geospatial data, and specifically in context with global warming. So let's get started with it. I'm going to share my screen for all of you to see and access to how to get access to geospatial warming data. And for that, you can find it here. Yeah. So if you go to your browser, your Google Chrome browser, and you type in interactive-atlas.ipcc.ch, you're gonna find this page, which is basically on like how global warming is going to happen in the next 50 to 100 years. And there are other uh, situations or different models basically. So we're going to go to the website, and you can see here, you can see the globe here, and basically like how the world would be warming when the earth would be warming at 1.5 degree, 2 degrees, 3 degrees, 4 degrees. So here you go. And if you want to have a better look at it, I would suggest you go to the regional information tab here, and then you click on advanced. And yeah, here it is. So right now, if you see, so this is basically CMIP6. CMIP6 is one of the models that a lot of scientists use when they are trying to visualize global warming. And this data set basically it's basically on mean temperature difference when the earth would be warming at 2 degrees. So when the earth would be warming at 2 degrees, you can see I mean, here is the legend here, and I don't think anywhere on earth you will find compared to the 18. So another important thing is so this is in relationship. So the temperature difference basically is is in comparison to the 1850-1980 average. So compared to that, back when, like what the temperature was back then, compared to that, how much would the earth be warming? So that is what the data set is all about. So as you can see, so there's a legend here which shows like the range is basically between -6 to +6. But as you can see on the map, there, I mean, hardly anywhere on Earth would there be a minus difference, as in like the Earth would be actually cooler than what it was back in 1850, 1900. And let's just face it, global warming is happening. Global warming is going to happen. So there's no chance of, like the Earth actually being cooler compared to 1859, 1900. So that's that. And now here, if we go, we have some scenarios that you have to look into. So first thing is we are going to select what is the model projection, which is CMIP6. Now there are variables, basically like data sets, like what variable are we looking into? Like what is the data sets that we are looking into? So there's mean temperature, there's minimum temperature, then there's precipitation data, and a lot of other things. You can go through it and you can select on your own. And if you want to, like, if you're curious, you can just go through it on your own. We are going to select mean temperature, basically mean temperature difference compared to 1850, 1900, which is right there, right now on your screen. And then we have scenarios. So that's what I was saying. So this data set, basically, you also have a lot of scenarios, like, so let's look into it one by one. So here you have the first one is the quantity, whether you wanted it to change, as in like change in temperature, or you want a value for it. Let me see what happens when we click values. Okay, so when it comes to values, you can see, so when the earth would be warming at, say right now it's 2 degrees, you can see, so the threshold limit is 40 to 40 degrees to minus 10 degrees, and I'll be interested in India, of course. So in India, if you zoom in, I'm guessing, well, most of it would be, I'm guessing, over 30 to 40, if you correlate it with the legend that is here on the side. So that's that. But we are looking into the change in difference. And yeah, and also like there are, so when it comes to the period, there's near term, which is 2021 to 2040, which is going to happen. And so how the earth is going to warm, what's the temperature difference going to be like when, you know, in the next 20 years, 2021 to 2040. Then there's medium term, which is 2041 to 2060. And, you know, there are other periods as well. We are going to select what's going to happen when the earth is warming at 1.5 degrees. Now there's also scenarios. Now scenarios are basically, so so like you might be just confused, like what is SSP? So let's find out what is SSP. Just a minute. Yeah. If we do a quick Google search, so you can find more information on SSP or what is SSP in Carbon Brief. Carbon Brief has a very good explanation of it. And I normally, you know, look into Carbon Brief whenever I am going through SSPs and different SSP pathways. So as you can see, what are SSPs? So SSPs are basically different modeling groups around the world. And so basically these are scenarios which look at 4 different possible future trajectories of population, economic growth, and greenhouse emissions. So that's about that. If you want to dig in more, you're most welcome to go through it yourself. But going back to the data set, so yeah, so you have to select one scenario, like you want the SSP1, SSP2, SSP3, or SSP5 8.5. I'm going to go for SSP5 8.5, which is the most extreme. And so, and there's also the baseline, basically, like, so if you see here, it's basically in relation to relative to 1850 to 1900, which is also selected here. And that's normally the way to go. You normally compare it with 1850 to 1900, but there are other periods as well. There's 1981 to 2010, there's 1961 to 1990, 1986, and, you know, like whatever periods you want to go for. And now let's get into the data set. Okay, so we have the data, and I'm going to zoom out a little. And as you can see, here's the map. So as per the map, you can see like the Arctic would be warming the most, which is again, I mean, we all kind of know, because the Arctic in fact is warming 4 times more than what the rest of the other continents are warming at. So the Arctic would be the one, like the change in difference would be the most at the Arctic region, and, you know, the polar region, basically the northern poles, basically. But like, we are from India, so you might just be curious as to what's happening with, like, in your state. So let me zoom in on India. And as you can see, I am guessing India would be warming at anywhere between 0 to 2. But I need a, but I need to know exactly what is the figure basically. What is the number? Like if we can give a number to it, you know, we keep talking about global warming and it's happening and it will happen and this and that. But what this data set will allow us is to actually will help us to give a number to it, which is the most important thing. Like we keep talking about, like we keep talking in vague terms about like what is global warming and is it, like some people actually question if global warming is happening, if climate change is happening. But through this data set, we can actually give a number to it. So like we need to know, like, so like when you talk about global warming in India's context, like, so at what rate India would be warming? So the question is basically like when the Earth would be warming at 1.5 degrees relative to the 1850-1900 average. So at what rate would India be warming, or at what rate would your state be warming? So that's the, I mean, the crux of the thing. Like that's the final the number that we want basically from an analysis. Like this is all good, like, you know, I mean, you can look at it, this looks pretty, you can make some assumptions and all, but then you can never be 100% sure. We can't, I mean, we can say like most parts of Arctic would be warming at 6 degrees or some around 6 degrees, but we can't put a number yet. You know, like I need to know, I want to know, I'm curious to know at what rate would my country be warming. So now we're going to look into that. Like, is there a way we can do that? And there is a way you can do that. You can actually quantify geospatial data. You also have to see, like, so this is geospatial data in the sense, this is basically spatial data. Spatial data is basically, they're only going to show you like how things are happening spatially in space, basically, you know, like, but in order to quantify it, like, and that's all any analysis, like me as a data journalist, because my work revolves around numbers and all, I have to give a number to it. So I have to quantify the data set here. So in order to do that, we are going to use a software called QGIS or Quantum GIS, which is basically a very popular software or tool that we use for geospatial analysis. So we're going to dig into that. And for that, so once you have everything set, like all the variables, like you have selected CMIP6 as your data set, for your variable, you have taken mean temperature or whatever. Like if you just go ahead, the process remains the same. You want to go ahead with precipitation, you're more than welcome to do that as well. I'm going to go for mean temperature, then quantity and scenario here. I have selected 1.5 degree, SSV 58.5, and a baseline of in comparison to basically 1850 to 1900 average. And there's one more here, the season. So I have gone for annual. You can go for December to February, March to May, whatever you want. I have gone for annual. So there's an annual data set basically. So here we go. So here there's the download button. If you can see on your right hand side, here's the download button. We are going to, so they give you three options. There's NetCDF, there's PNG, and there's GeoTIFF. So these are basically, you know, different types of like different formats for geospatial data. PNG would be a little difficult. I mean, there is a way, but I'm not getting into that. If you're interested, you can look it up on Google on how to do geospatial analysis on PNG. But so now it's between NC and GeoTIFF, and I'm going to go for NetCDF. You can also go for GeoTIFF if you want, and if you guys, again, like if you guys are curious to know, you can most welcome. You can like do a quick Google search and find out like what's the difference between NetCDF and GeoTIFF. But more or less, these two are primarily the ones that we use for geospatial analysis. Mostly, in most cases, if you see a geospatial data, it will mostly be in NetCDF format or a GeoTIFF format. I'm going to go for NC, and I click it here. Okay, so now let's dig into QGIS. So as you can see, I have my QGIS open. I'm using the QGIS 16 version, LTR. Uh, you're most welcome to use any version that you want on QGIS. The process remains the same again for quantifying the data set, so that's not an issue. So here we go. So I go to the file directory where I have saved my netcdf file, and that's in downloads. Yeah, okay, so yeah, so and please ignore so many files I had earlier downloaded it. I'm gonna use just pick one, the one that I just downloaded now, which is this CMIP6 mean temperature. Yeah, this one. And once you drag it here in your layers panel, so, but this is all black and white. And if you see here, uh, this one is visually more appealing and also explains it better. There's more context to it. So what do we do? So firstly, here's the file, and it shows that the range is between 0.50 to 6.2 degrees. Yeah. So we right click on this file, and then we hit properties. And then there's this tab that opens, this window that opens up, and here's information. This basically gives you information about the file you're working on. And there are other things as well. We go to symbology, and we are going to select single band pseudo color. And yeah, and so here is the color ramp, if you see. And you can play around with the colors that you want. I am happy with this, the color that QGIS has selected for me. I'm gonna hit apply. Okay, okay. But now we need some more context to it. Like, there's just like, I can make out like, okay, this is North America, this is South America, Africa, this might be India, Australia, but we need some little more context to it. So we are going to include a shapefile. A shapefile, as you know, is basically a vector file. We could be asking like, what's a vector file? So a vector file is something like this is what you're seeing right now, CMIP6, that is a raster data. So a raster data, as you can see, there are a lot of pixels, right? You see, there are pixels here, so I mean, it's all bounding, like, so like if you stretch the image, it's going to get pixelated, but with a vector file or a shape file, no matter how much you stretch the image, it's never going to get pixelated. And it's basically made up of points and lines. I'm going to show you an example of a shape file. If you go, so for the shape file that we are using, you can go to DataMeet. DataMeet is again a portal that we data journalists use a lot for our maps and everything, and it has a lot of raw data. You can find, as you can see, you can find assembly constituencies, parliamentary constituencies, state boundaries, and etc. etc. And we're gonna go. So is it this one? No. I'm just looking for how to download this. I think it's this one. Yeah, I think so. So yeah. So I'm gonna go for states. So if you click on this, states, here you can actually, okay, so you can actually download everything at one go. You don't have to like individually, you don't have to download the constituencies and then boundaries and all. You click on that, download everything, and it downloads. And I'm gonna go back. I already have it downloaded, so I'm not gonna download it. You guys please can go ahead. I'm gonna go back to QGIS, and I'm gonna go back to my file directory where I've saved all the shape files, and it's here in desktop. It's QGIS project, maps master, states. Okay. Or I can also go for like, so since we are looking at it from a global perspective here right now, I'll rather go for world continents or world countries. Yeah. Or anyway, I think I'll just go for the states. Yeah. I'll just go for the states. Yeah. So once you drag it here in the layers panel, you see this thing coming up, and I'm going to change the color. Use the fill color. So I'll have zero transparency, zero opacity. So yeah, okay. So now we have a nice map of India on top of our raster file, the data set. Now, as you can see, so this is how it's looking. But we want to be sure, like we want to know at what rate your state is warming up. So like I'm from West Bengal, so I'll be interested in knowing, so like when the earth would be warming at 1.5 degrees relative to the 1850-1900 average, my state, West Bengal, would be warming at, well, like what's the temperature difference going to be compared to the 1850-1900 average? So how do we go about doing that? Because this is a, there's a geospatial data. I mean, it only shows like spatial distribution of, of how warming is going to happen. And what we are talking about is actually giving a number to it. And so basically, we want to quantify the data. Basically, we want to know basically what is the number. Because like since we are dealing with numbers here, we want to know what's the number behind it. So what do we do is basically we go there and here is the processing option that you have, and we click on toolbox. Again, I'm showing you once more. So this is basically, so like as you can see, it's like there's the browser panel, there's the layer panel, and here's basically you can call it, like I call it the artboard, like where you display the data. So that's that. And here you have, so like you have all the options. You have a project, edit, view, layers, settings, plugins, and I'll go for the processing one. So here, so that's just next to window, and I'll go for processing, and I'll click on toolbox, and I'm going to go for zonal statistics, and I have to do some selections here. So the input layer is going to be my shapefile, which is admin2, which is basically the states of India, and my raster layer is going to be the the original data set. Raster, so there's this option raster ban. We're going to check once more. So there's, okay, so there's band one. So we're only going to select band one. Band one, yeah. And so, and here's the option, like, what are you trying to calculate here? So there's count. I mean, if you're familiar with Excel, you'll be knowing like these terms, like count. Basically, what's the count of it? What's the count of all the pixels? We don't need that. That's not like not applicable for the kind of calculation that we want to do. There's also sum, which again we don't need basically, because I mean what we need basically right now is the mean of it, like the so this calculation is going to give us like, so for your state basically what's the mean temperature difference going to be. So we need the mean for it, and we're going to select, we're going to keep that highlighted, and we're going to go back and we're going to run. Here we go. So statistics. We are going to select zonal statistics. This was the file that was created, by the way, when we did that, when we opted for that mean calculation. We are going to open the attribute table here. And here, okay, so here we have the numbers. So I was looking for my state, which is West Bengal. So West Bengal, so like when the Earth would be warming at 1.5 degrees, my state would be warming at 0.81 degrees, or like whatever the number is. So that's the way you go about doing it. And if you want to, so this is all fine because this is just like 36 states. So you can just like, write it down or anything. But you do still want an Excel file, like where you have all the numbers in like one sheet, basically at one place. So what you do is you're going to go there, you're going to do a right click, you're going to go to the export options and then save feature as this file name. Firstly, I am going to save it as India states warming. And I'm going to save it on my desktop. And then I am going to save it as a CSV, which is comma separated value. And everything remains the same. Yeah. Okay. And yeah, here we have it. We're going to see if that has been saved. And so I'm going to open it once more. Yeah, here we are. So here are the mean values, and you can do your analysis now if you want. I'm going to show you how India is going to look. So I'm going to select zonal statistics. I'm going to go to properties, and just like we did with the raster file, I'm going to do the same. I'm going to change the I think this is, I think, no, this is fine. What I'll try to do, what I'll try to show you another thing is basically, so this is for India and we want it for world as well. So what do we do? So I'll just do a quick thing with my computer here. And just and go to world continents, world countries. Um, yeah, and I am going to run countries and I'm going to refresh it. So if you see, so this is the shapefile that we want for world countries. And I'm going to drag it here. Yep. And I'm going to leave statistics. So this is the one. No. Is this the one? Just 1 minute. Let me just. Or let me do it this way. I'll just show you the file from where you can download this. This is India Viz. You search India Viz on Google search. Sorry, India Viz. Yeah. Yeah, this one, India Viz. You can see the year here, indiaviz.org. You go here. We are looking for World India Geodesium shapefile. We're going to select that. We are going to, let's see if the shapefile works. Let me just open it. So I think there's some problem with the shapefile, so that's why I wanted to show you. You go for the JSON one, and you select that. And yeah, I think it's this one, this file. So we're going to go back to our QGIS, and then we're going to refresh it, refresh the browser panel. And then I'm going to go to the file directory where I downloaded it. Here it is. So the file name was NE10M. So I'm going to drag it here. Yeah, so just give it some time because it's a little heavy file. It's like over 20 MB. So, and I think it's now QGIS is now processing it. So whatever time it takes to, yeah, and here we are. I'm going to delete this. And like I did with the other files, first we're going to bring down the opacity of it. So it's going to be 0 opacity. Okay, so now we want to know, so like which countries would be warming at what compared to the 1859 standard average. And we're going to use the same, like the zonal statistics. So we're going to go to toolbox and we're going to first select zonal statistics and everything remains the same. And I'm going to go for mean and run. And here we have. And we're going to want the open attribute table. And so there are a lot of properties, you know. So what we are looking at, yeah, so we are looking at mean. So here's our number. Here's the number that we want. And just like I showed you earlier, we're going to export it, say feature as global warming. I'm going to name it. Everything remains the same. Just the desktop. Save. Okay. And we're going to go back and we're going to check if the file is working. We have the data on the file, and this one's going to be global. So let me just go back and check it once more. If I had saved it in the properties, I'm going to go back once more and save features. Or I'm going to just do a quick global warming. Yeah, so I do have the CSV. Yeah, here's the file. What we are looking for is the mean. So what I'll do is I'm going to select the country, this one. And I'm going to select this column. I'm going to copy it. Yeah, so here we have, now we can look at it and we can do our analysis. Whatever analysis you want to, you can please go ahead. But this is basically the process of quantifying geospatial data and getting more context and doing more analysis, the kind of analysis that we want to be doing. So I think here I think we are almost done with our geospatial analysis video. And I'm going to leave it here. If you have any questions, you can always mail me at pulaha.cscindia.org. So thank you again. Thank you for joining us. Again, like if you have any queries, please feel free to get in touch with me, and I'll try my best to help you guys to do whatever geospatial analysis that you guys want to do. Doesn't have to be this particular data set. It can be anything. It can be precipitation data, any other climate change data, or anything. So yeah, that will be all. I'm going to stop the video here. Thanks again. Thanks a lot for joining us.